Welcome back to my today's session on electric field and polarization of electromagnetic field. Myself Dr. Sayanti Chatterjee, Associate Professor of Department of Electrical and Electronics Engineering in Institute of Aeronautical Engineering, Hyderabad. So, electric field and polarization is an important topic in the electromagnetic field. So, while we are discussing this, first thing comes in our mind, what is the conductor? Because while we are thinking about the field, the first thing comes in our mind, what is a conductor? A conductor or electrical conductor, already this is discussed in the previous session also. Just one quick recap. A conductor or electrical conductor is a substance or material that allows electricity to flow through it. In a conductor, electric charge carries usually electrons or ions which can move easily from atom to atom when voltage is applied. So in a conductor, if this is a conductor, it comprises of some positive charge and negative charge. And while we are connecting any voltage to it, and it will create some field. And as a application of the field, the positive charge and negative charge will be segregated, and the electron starts to flow from negative to the positive side. So the direction of current will be opposite from the flow of electrons. So what are the properties of the conductor? So a conductor always allows the movement of the electrons and ions through them. The electric field inside a conductor is zero, allowing electrons to flow within. The general tendency of the electric field is to stay on the top of the conductor. The charge density inside a conductor is zero. Many metals are good conductors of electricity, and this is the reason why many of the applications we need to make of the metal. Generally, we use the copper, silver, this type of metal as the conductor. Another one is the important thing which is discussed in the previous class also. What is a dielectric? A dielectric material is a poor conductor of electricity but a good supporter of the electrostatic field. As today our topic is the electrostatic field and polarization, the dielectric has the most important role in the discussion. So a dielectric is very poor conductor of electricity but an efficient supporter of the electrostatic fields. Its two electric charges have a high specific resistance and a negative temperature coefficients of resistance. So what is the thing? The specific resistance is very high in case of a dielectric medium, but it has a negative temperature coefficient. If we increase the temperature of the dielectric at a certain point, it will break down and it will behave like a conductor. So the property already discussed is the electric susceptibility. Electric susceptibility refers to a relative measure of how easily the dielectric materials can be polarized. Next one is the dielectric polarization. This is our today's topic, dielectric polarization. We will discuss the dielectric polarization today. So this is the amount of electrical energy stored in the field when voltage is applied to it. Since it causes the positive charges and negative charges to flow in the opposite direction so that it can nullify the overall electric field. So that's why the dielectric has the poor conductivity of the charge. Next one is the electric dipole moment, which we will discuss in the today's class also. Electric dipole moment means if two charges of equal value but opposite in the signature, opposite of the sign, if they are apart from the same distance, the positive charge and negative charge will try to nullify each other and it creates a dipole moment. Next important is the relaxation time. We are also discuss this topic today. Upon removing the electric field, the atoms in the dielectric material try to return in their original state after some delay. So the delay time is referred to as relaxation time. Dielectric breakdown, which is another important thing. If we give the more voltage across the dielectric, it will break down after a certain time, and this is called the dielectric breakdown. And like for air, the value is 13 kilovolt per centimeter. Sometimes due to the puncture and sometimes the metal body, if the dielectrics are made of the solid things, it will also break down and it creates a permanent damage in the like porcelain or the glass. If the dielectric breakdown occurs, it will breaks the solid dielectrics also. And dispersion. Dispersion is the maximum polarization attained by a dielectric material. While we are polarizing the dielectric material, how much polarization it can take, that can be discussed using the dielectric dispersion. So up to these two topics already discussed in our last lecture, and today we have given a small recap of these two topics. Now we are going to our today's topic. What is this? First one is the electric field inside a dielectric. What happened if we give some electric field in a dielectric? So, when an external electric field is applied to a dielectric, the charges align such a way that an internal electric field is produced. So, say we have a dielectric material and we are connecting it with a battery. This is a dielectric material. We are connecting it with a battery, and what will happen due to this positive and negative charge? Inside also the charge will adjust themselves such a way that it will create some electric field. Next, the magnitude of the internal electric field is smaller than the external electric field. Always, which you call the internal, if we have a battery, we know there is some voltage drop or something like this. So, internal electric field is always smaller than that of the external electric field. Therefore, what will happen? There is a net electric field in dielectric is not zero and is parallel to the external electric field with the magnitude less than the electric magnetic field. As the external and internal, there is some difference. So, there are some net electric field always be there. Say we have a dielectric medium here. We are giving some voltage of 5 volt, and inside the voltage is 4.5 volt. So there is a or 0.5 volt. So internally there is a net electric field. Inside is 4.5 volt, which always which the direction of this is parallel to the main electric field. If this is positive, this is also positive. If it is negative, this side will be also the negative. When the external electric field applied to the electric material, the material becomes polarized, which means it acquires a dipole moment. So what is happening while we are giving, say we are using some air or some water or air or any liquid or any solid dielectric material, and we are connecting an electric field, what will happen? The dielectric medium will break down. It is called the polarization. Positive will go one side and negative charges will go inside, and if the both charges have the same magnitude and they have an opposite in direction, they will create some dipole moment, and this dielectric property is known as the polarizability of the dielectric medium. This is an important property of the dielectric. So we are giving, let us consider a rectangular dielectric slab between two oppositely charged plates, that is called the capacitor. In the case of the capacitor, if there are two parallel plates and there are some dielectric material. If we connect it with a battery, what will happen? Here if we get the positive charge, here we will get the negative charge, and it will gives the rise of the capacitance between the two. So this is the important property of the electric field inside a dielectric. So similarly, if we discuss these things, unlike this, there is the opposite thing, that is the behavior of the conductor in an electric field. So conductors have electrons which are not bound tightly. In the dielectric, the electrons are tightly bound. But in the case of the conductors, the valence bond or the bond of the conductors are lightly bound with their atoms. These are free to move within the conductor. However, there is a net transfer of electrons from one conductor to another conductor is not possible in the absence of the electric field. Say if we keep a copper wire idly, maybe there are some loose electrons, but there is no flow of electrons, so no flow of current. But if we connect the conductor with a external field, that is called the voltage. So what will happen? The electron starts to move to nullify the effect of the electric field, and what will happen? The current will flow. So if there is no voltage is applied, there is a no net transfer of electrons. In solid conductors, now conductors may be solid, may be liquid. So in solid conductors, free charges moved randomly in all the direction during the thermal agitation. We know this process, that due to the thermal agitation, the solid conductors free charges will move in all direction, but their net effect becomes zero. If there is a copper and if we heat the copper conductor, due to the thermal agitation, the free electrons, as they are loosely bound, they will start to move randomly. As the direction is random, the current is zero. So there will be no electric current inside the conductor. We checked in the dielectric, there are some field inside the dielectric. But in conductor, there is no charge, so there is no current inside the conductor. So when the field is applied, the electrons move in the opposite direction of the electric field and constitute the electric current. Next important topic is the electrostatic shielding. What do you mean by the electrostatic shielding? It is a phenomena of protecting a certain region of space from the external electric field. See, we have a very costly or delicate instrument, like we have the mobile charger, we have the laptop charger, which the charging is the copper wires inside it, and they are very delicate. So if there are some external electric field, so it is not possible. Or you have a CRO, we have a TV, so all are the very delicate instruments. So if there are some lightning, we can know in sometimes if the certain lightning is there, that TV blown off or something is happened in our household. So what is this? They are always kept in a hollow conductor. We kept in this is called the shielding, or we call it the electrostatic shielding. So what are the main difference of a conductor and dielectric? Electrons are inside here. Electrons are on the outer surface of the conductor. There are no free electrons, but there are free electrons. In the dielectric, energy is stored, and what is the value of the energy? Half CV square, where C is the capacitance and V is the applied voltage. But in the conductor, there are some heat energy due to the Joule's effect. Some energy is dissipated, and the value is the I square. Our energy value is the I square, half I square RT. So what is this? This is due to the resistance of R is the resistance. If we go for the difference between the dielectric and insulators, Materials that can be developed. Now, sometimes we think that the dielectrics and insulators are same, but there is a small difference. Materials can develop an electric field with minimal loss of energy is known as dielectric. A substance that has low conductivity and which obstacles the flow of electrons is known as the insulator. So insulator is not same as the dielectric. Insulator means which have the high resistivity or low conductivity and it obstructs the flow of current. In any condition they stop the flowing of current. But in the dielectric is material which develop the electric field with minimal loss of energy. They have the weakly bonded as compared to insulator. They are covalently bonded. The bonding of the insulator is very tight, but in the dielectric, it is not, I am not telling weaker, it is weakly with respect to the insulator. It can store charges. So in the capacitor, we know according to the definition, as they are dielectric, it stores the charges. But here it obstructs the charges. Insulator stopped flowing the charges only. Their application lies in the power cables, and this is for the high voltage like porcelain, glass. These are the paper, impregnated paper. These are the insulator, but dielectrics are the air is a dielectric. Then another dielectric is the some we can use in the power cables. So now we will discuss about the motion of a charged particle of an uniform electric field. If there is an electric field, what will happen if the one motion of a charged particle is goes? So if the electric field E is uniform, generally electric field is not uniform, but for the simplicity, for the ideal case, we are taking the electric field E is uniform in magnitude and direction. The electric force F on the particle is the constant. So what is F? F is equal to Q into E, where E is the value of the electric field and what is Q? Q is the number of charge. So you can see this is a paper and this is the input signal. This is a deflecting plate. This is connecting with a voltage. So there is some electric field. Now if any charge wins, it will be deflecting. It is not going in a straight line. So if a particle has a positive charge, its acceleration, it has some acceleration A and electric field F in the direction of the electric field. So we can write A force is equal to Q into E is equal to mass into acceleration. Whose mass is this? This is the mass of the charge or number of charges. So what is the speed? What is the acceleration? QE by M. Q is the charge, E is the value of the electric field and M is the mass. So if the particle is negatively charged, its acceleration A and F is in the opposite direction of the electric field. And as there is some deflecting field from the gun, this is called the electron gun. This is known as the electron guns. Electrons will come out and it will be deflecting. If the charge is there, it will be deflecting in nature with an acceleration A. If we keep any screen, any paper, so it will show the electrons some point on the some luminous point. This is generally used in the CRO, cathode ray oscilloscopes, works on this principle, on the working principle. Next, we will discuss about the dipole moment. What is a dipole moment? Already we discussed little. If two charges plus Q and minus Q, means if the two charges have the same value, same magnitude, but they are opposite in direction and they are separated by some distance D, forms the electric dipole. The distance traveled by the point charge is defined by as the dipole moment. What is dipole moment? The product of the charge and distance traveled by it. The product of the charge means Q into the distance traveled by them. So P is equal to QD. We will just taking the magnitude, not the direction. And as I told, P is the electric dipole moment and D is the distance between the opposite charge. The line between two charges is called the axis of dipole. This D is known as the axis of dipole. So a dipole results from the displacement of the charge, and dielectric is known as the polarized. We tell the polarized glass. What is the meaning of the polarized? Polarized results from the displacement of the charge and dielectric. What is the exact path? We are changing the direction. The electron cloud is distorted by the applied electric field E. The distorted charge distribution is equivalent and the principle of superposition to the original distribution plus dipole whose moment is P into QT. So, this is a special point about the dipole moment. The dipole results the displacement of the charge and the dielectric said to be polarized. So, then if the polarized state, the electron cloud means a many electrons is distorted by the applied electric field E. Next, what is dipole moment and deduce is expression. So, a dipole, so already we know what is dipole. So, the dipole results from the displacement of the charge and the dielectric is said to be polarized. Already we have discussed. In the polarized state, the cloud is distorted by applied electric field and the dipole moment is known as the P into QD. What is Q? As it is not a charge. Q is the summation of the each charges. N is equal to 1 to K. So, if there are the Q charges, we can write Q1 into D1 plus Q2 into D2 plus Q3 into D3. So, if many charges, if there is a positive and negative dielectrics are there, if we connect it with a battery, so all are the positive, all are the negative. The value is Q1, Q2, Q3, Q4 and the distance is, this is also minus Q1, minus Q2, minus Q3, minus Q4 and the distance is maybe same, maybe different. So it is, I am taking at D1, D2, D3, D4 like this. So what is the overall dipole moment? Q1, D1, Q2, D2, Q3, D3 is known as the dipole moment. So we can write limit delta B tends to 0. Delta B is a very small value between the voltage difference between the two charges. Those we are thinking that both are same, but if there is a small value, so it tends to 0. K equals to 1 to N QK dk by delta B. So this is the overall dipole moment for an electron cloud. Not for single electron, for one electron, the value is P is equal to Q into D. Next is the explain the dipole in the electrostatic field. So we know the dielectric moment. So what is electric dipole? Electric dipole is formed when 2 point charges are equal magnitude but opposite sign are separated by a small distance. So this force, there are two type of force. One is plus QE, another force is minus QE. When they work, then it is called the dipole. So when an electric field is applied, the positive charge is displaced from the equilibrium position in the direction of E by the force. The negative charge will be also displaced by the F by Q. Say this is one charge plus Q. This is a charge minus Q. If it, due to the dipole moment, if it's shifted from here to here by D amount, it will also shift from here to here by D amount. So there is a dipole moment. It looks like, and if it is an equilibrium point, if we are changing this, it will also, the another part will be moved the same amount due to the dipole moment. So what are the dipole moment property? So first property is, it is a measure of separation of positive and negative electric charges within the system. The SI unit, the unit as we know, the value is equal to P is equal to Q into D. So Q is coulomb, D is meter. So the unit is coulomb meter. The major effect of the electric E is the creation of the dipole moment that align themselves in the direction of the E. So there is a general tendency of the dipoles that they will always try to change its position in the direction of the dielectrics. This type of dielectric is known as the non-polar. Hydrogen, oxygen, nitrogen and the rare gases are the example of, these are the example of the dielectric, as well as they have the non-polar dipole. So while for these gases, if we give the electric field, the polarized the polarized atoms will arrange themselves in the parallel to the electric E, so that it can minimize or nullify the effect of the electric E. So this is called the non-polar. But when an electric field E is applied to a polar molecule, the dipole moment experiences a torque to align on the dipole moment parallel to E. So for the polar things, the dipole moment is there, which will try to align them in parallel to E, and this is called the polar. What is the example of the polar? The polar example is the water, H2O. So if we breaks, it will try to, if we give the voltage, it will try to align themselves in the direction of the electric field so that current can flow. So the examples are water, sulfur oxide, hydrochloric acid. These have the built-in dipole and they are said to be polar molecule. So we have discussed about the non-polar and polar. So what is the value of the torque due to the electric dipole? You can see there are plus Q and minus Q, and we are giving a field of electric field of E. So Q1 will, if the distance is D, it will feel a force, and the value of the force is F1 is equal to E into Q. Similarly, this will also in the opposite, this is a negative charge, so direction of the force in the opposite direction, and F2 is equal to minus E into Q. So this is the plus E into Q and this will be the minus E into Q. So what is the total force? Total force is F1 into F2, EQ minus EQ. So what will be the value? This value will be EQ minus EQ. So force will be 0. But due to the force experienced by plus Q tends to oscillate in the direction of E, and minus Q will try to oscillate them in the opposite direction of minus Q, which leads some torque of the dipole moment. Though the net force is 0, as this if this is the direction of electric field, it will be in the same direction and another one will try to opposite. So what will happen? As a result, there is a leads to the torque of the dipole. So what is the value of the torque? We generally know torque is equal to magnitude of the force into the perpendicular distance between the line of action. So what is the perpendicular? This is the line of action. If O is the equilibrium point, so we have to calculate the distance D. So what is the value of the distance D here if the angle is theta? So value is, if the distance is r, so this value will, if this is the angle theta, so what is the value? R sin theta. So from here r sin theta and here r sin theta. So it is coming 2r sin theta. This angle is theta. This angle is r. So sin theta is equal to distance x by r. So x is equal to r sin theta. So this distance is r sin theta. Similarly, this distance, as this is an equilibrium point, is r sin theta. So it will be 2r sin theta. So what is the magnitude of the force? We got already, magnitude is E into Q. So torque is equal to EQR sin theta. So the value is the 2 EQ into R sin theta. Now, what is the value of the Q into 2R? Q into 2R. What is the distance between these two? If this is R, we are assuming this distance is R. So what is D? D is equal to, we know D is equal to 2R. D means the distance between the two charges. And previously we have already discussed the dipole moment P is equal to Q into D, or we can write Q into here 2 into R. So we can write it E Q into 2R into sin theta. So E Q D sin theta, and QD is equal to P. P is equal to the dipole moment. So we can see P is sin theta because Q into 2R is equal to P. So this is the torque between the electric dipole. Torque between the electric dipole. Next, we are moving to our next slide, that the electric susceptibility. Electric susceptibility is generally used for the dielectric medium. Electric susceptibility is a dimension proportionality constant that indicates the degree of polarization of a dielectric material in response to an applied electric field. So P is directly proportional to E, and P, if we make it equal, it is K into E. K is equal to P by E. So it is known as the electric susceptibility. And what is the relation between the electric susceptibility and dielectric constant? In the dielectric constant with the polarization, D is equal to epsilon E. Generally, D is the electric flux density. So we know D is equal to epsilon into E, and P is equal to xi epsilon into E. So epsilon R is equal to xi plus 1. Epsilon R is equal to xi plus 1. What is polarization? Polarization is also called the wave polarization, is the expression orientation of the lines of electric flux in an electromagnetic field. If there is an electromagnetic field and there are some electric polarized material, the direction of the electric fluxes is known as the electric polarization. Polarization is also defined as electric dipole moment per unit volume. The main definition of the polarization is electric dipole moment per unit volume. So we can write polarization capital P is equal to dipole moment per volume. So what is if the distance between two charges is L? So what is the dipole moment? If the charge value is plus Q and minus Q, dipole moment is Q into L. And what is the volume? Volume is equal to cross-sectional area per cross-sectional area into length. So we can write that the Q into A, so charge per meter square or coulomb per meter square is known as the dipole moment. So dipole moment is also equals to the rho s, or we can tell it the surface charge density, but it is the numerically, physically there is no relation between the surface charge density and the polarization. So what is the electric dipoles? We have already discussed that you can understand from here easily. If we think about the water is the H2O. H and H is the positive polarity and oxygen molecules are the negative polarity. So there is a general tendency of the positive charge to create some dipole moment at the center. So it is a permanent dipole moment. Always there is a dipole moment, and this type of things, if we give the little field also, it will easily break down. So what is the dipole in a uniform electric field? A dipole in the uniform electric field experiences the equal and opposite forces tend to rotate the dipole, so the dipole moment is aligned with the dipole field or the torque. As I discussed earlier, the dipole field always tries to rotate such that creates some torque such that the conductor will align itself in the parallel to the electric field. And we have also discussed that torque is equal to PE. We already discussed that the torque is equal to PE sin theta, or we can also write it, if we write in a vector form, P into P cross E. Torque is equal to P cross E. Already we have discussed this in the previous slides also. The torque is equal to PE sin theta. So we can write it as the P. If we take the torque value as a vector, torque is equal to P cross E. Torque is equal to P cross. So in a non-uniform electric field, the dipole experiences a net force, and here the point charge polarizes a non-polar molecules and attract it. If the field is non-uniform, till now we have considered the uniform field, but what will happen if the field is non-uniform? In the case of the non-uniform electric field, the dipole moment experiences a net force. So it will attract the polarized non-polar molecules. Illustrate the expression for electric field intensity due to dipole. If we are thinking about the electric field, what is the about of the electric field intensity. So this is a charge plus Q and this is a charge minus Q. We are giving some voltage, and what is the value of the voltage? V1 is equal to KQ by R1. R1 is equal to the distance from a point P. And if we want to bring this one, so V2 is equal to, so this is the V1. What is the V1 for this small circle? What is voltage? The time taken to take one charge from one point to another point. So distance is R1, K into Q by R1. And what is V2? And what is the value of the R1? If the distance is X, from here, so if this distance is A, so it is X minus A. This distance we are taking as Y. X, Y. The coordinate is X into Y. So R1 is equal to root of X minus A squared plus Y squared. So what is V1? V1 is equal to KQ root of X minus A squared plus Y squared. Now what is V2? V2 is due to this charge. So it will take K minus K, because the charge is minus Q, minus KQ by R2. What is R? This point is X. So this is X and this amount is A. So what is this distance? This distance is X plus A, but this height is same. So what is R2? So we are taking this circle. So what is R2? R2 is equal to, this is not R1, this is R2. R2 is equal to X plus A whole square plus Y square. So what is V2? KQ root of X plus A whole square plus X Y square. So what is V1 plus V2? KQ. So V1 we got. So V1, V is equal to V1 plus V2. We are getting the KQ by root of X minus A square plus Y square, and from this equation we are getting minus KQ root of X plus A square plus Y square. If R is very greater than A, if this distance is very small, we can omit, we can write that root of X plus A square, we are removing it with R. So R square plus 2AX, we are minimizing the value. So what is X? X is equal to, if this distance is R, X is equal to R cos theta. So we can write that root of R square plus 2AR cos theta. So if we minimize it, we can get the value of the V. Just putting the value, the substitution. So in this chapter, we have discussed about what is polarization, what is conductor, what is the properties of the conductor, what is dielectric, what is the properties of dielectrics. These are the small recap of the previous section. Then we have discussed about the polarization, dipole moment, susceptibility, the torque due to the what is polar, what is non-polar, what is polarizability. Then we have discussed about the torque due to the dipole moment, what is the effect of the dipole moment for the electronic cloud, and last we have discussed about the electronic field. So up to this is my today's lecture, and thank you all.
Like, share and subscribe. Hit the bell icon for more updates.